All right, everybody, welcome back. 2.2, I'm excited. Creating and storing objects, or in other words, instantiation. We have a series of learning objectives and topics on the screen, so let's get started. Oh, we're starting with a notional machine. All right, let's take a look at it. On the left, you have some code. You should read through that code and try to figure out what that code is doing. All right, let's get started looking through our main method. On line 3, we have a variable declaration and assignment statement. We are declaring a variable called numSides that will go into our stack memory that drops all the way in the bottom of our stack memory, numSides, and we are assigning it the value of 20. On line 4, we have something that kind of looks like a variable declaration statement, but it is different. So this is an object declaration and instantiation statement. So you will see that it starts off with using a class name, die. We have our class die down here. Now our class, like we learned before, is made up of variables. This has one variable for the number of sides. It has a constructor to build that die for us. So we have one constructor where we can pass in no parameters, and it'll set the number of sides to 6. And then we have a second constructor to call. We have two ways that we can build a die. So we can pass in the number of sides, and then it will use our number of sides and store that for the number of sides. And then we have one method, that's our behavior, that's something that our object can do. And we can roll this die and it will give us a random number based on the number of sides that it has. So we are going to construct a die. Now we are going to give that die a name. So we are giving it the name D6. Now, if you're unfamiliar with dice lingo, a D6 is just going to be your normal 6-sided die. That's just called a D6. So we are giving it the name D6. That name goes into our stack memory in our next available location, which is right here, D6. And now we need to give it a value. Well, we are calling a constructor. We're calling the constructor that accepts no parameters. So that brings us down here to line 6 in our class. We're calling that constructor. It makes a variable called sides, because that's what we get when we create this object, and it's setting sides to 6. Now, since this is object data, our object data gets built in our heap memory. So we are going to create a variable called sides, and we're going to assign it the value of 6. Now our variable D6 needs to know where to find that object data, and it is in heap memory at position 1. So the value that gets stored for D6, it's going to tell us that we have a die at heap memory 01. Now at this point, you might be saying, hey, that's confusing. Why don't we just store the number of sides in stack memory? Why don't we just put the 6 right there and be done with it? Well, a class can have multiple variables. So when you think about a die doesn't necessarily just have the number of sides. A die could have a color, and then a die could have like a transparency level, how see-through it is. So a class can have multiple variables, and we cannot store multiple values in one location in stack memory. So an object needs to have all of its variables built down in heap memory, and then in stack memory, the object that we declare will just hold an address of where to go to find all of those values. We're going to go back into our main method and we're going to look at line 5. And we are declaring another object from the die class, and we are giving it the name D20. So in dice lingo, that's going to be the 20-sided die, which is common if you play tabletop role-playing games like Dungeons and Dragons, you will see a 20-sided die. So we are declaring that object. So that is going to go into our stack memory. We gave it the name D20. This time we are calling a different constructor. Remember, we have two constructors. We have overloaded constructors. So we're going to call a different constructor, and we are passing in a parameter num sides. Well, we can look into our stack memory and we can see num sides. Num sides has the value of 20. This will evaluate to a 20, and we're going to pass the 20 in as this parameter. So it gets a copy of that 20. It actually doesn't get this variable from stack memory. It gets a copy of it. So it just gets a copy of the value. And so then it's going to take that 20 and it's going to store it into a variable called sides. Well, the objects variables get created in heap memory. So we're going to have another one called sides in here. And then this is going to get a value of 20 assigned to it. And then the constructor will then give that address back so that can be stored with the variable that we created. So D20, it's going to know that it has a die at heap 02. Looking back in our main method on line 6, we are declaring another object from the die class. We are calling this one D12, and in tabletop role-playing, that is a 12-sided die. And so we are going to create that in our stack memory, D12. But you'll notice that there is no constructor. We're not calling any of the overloaded constructors. We have two overloaded constructors down here that we could have picked from, but we didn't pick any of them. So we're not actually building the die. We just said, hey, I just want space and memory where I could build a die that I called D12, but I'm actually not building it yet. So nothing goes down into heap memory because we have not instantiated those member variables to a value. So we don't get a memory address up here in heap memory, but something needs to go there. Java has a very special keyword. That keyword is called null. Null means that there is nothing there. So we said that we are going to try to make an object at some point with the name D12. We haven't made it yet, so Java puts in the keyword of null. Now we're going to explore all of this in more detail as we go through the rest of the topics. So let's see what we have coming up next. So we're going to take a closer look at those constructors. We're going to hit two of our learning objectives. We want to identify, using its signature, the correct constructor being called. And for creating objects, we're going to create objects by calling constructors without parameters and create objects by calling constructors with parameters. So have you ever been invited over to a friend's house to play Dungeons and Dragons? And when you get there, I don't know, you expect to go on an adventure, maybe in a dungeon, perhaps with some dragons. But then you get there, and instead of a dungeon, you see a pile of dice. And instead of a dragon, your friend hands you a book. And now your friend, who only answers to Dungeon Master, tells you that you can't play until you have a complete set of dice. And then they hand you an order form that clearly has their name on it, and they are trying to sell you some dice. And instead of playing Dungeons and Dragons, all of a sudden you're involved in some kind of pyramid scheme. So you start looking at this order form, trying to figure out the perfect way to construct your dice set. And you have a couple of different choices. So maybe you don't know anything about ordering dice and you just want the basics. You're just going to get a plain red 6-sided die. Or maybe you want some personalization with your dice and you want to be able to choose the number of sides that you get on that die. Or perhaps you'd like the most level of control where you get to pick the number of sides, but then you also get to pick the color. So you have 3 different ways to construct that die that you are going to get. So in the last lesson, we said a class was like a blueprint. So we can have a class for a die. The variables are the attributes, That's the way something looks. So we expect a die to have a number of sides, and we expect a die to have a color. And then we have our methods. Remember, our methods are behaviors or whatever we expect an object from that class to be able to do. And we would like to roll that die, and maybe we can change the number of sides on that die. So we have our class definition on the right. We see our variables on line 3 and 4, our int sides and our string color. And then we see our methods on lines 7 through 14. Well, we're going to try to squeeze something between the variables and the methods. This is going to be our constructors because we need a way to build the objects that these classes define. And we want multiple options for how we can construct these objects. So for our die class, we are starting off with two different constructors. One constructor where we give it no additional information and it's just going to make a 6-sided die. And then we have a second constructor where we can tell it the number of sides that we want, and it will initialize the sides variable to our choice. So if we pulled a constructor out of that class, we want to kind of understand the anatomy, the parts that make up that constructor. Constructors start off with a name, and that name has to be the same name as the class. The constructor's job is used to initialize the object. It's going to set the member variables so that your object is unique. In order to make a unique object, it's going to need some information from you. So it's going to have a parameter list. A parameter is a variable whose value or reference is passed into a method. So this die wants two pieces of information from you. It wants to know how many sides you want and what color you want your die. These are known as our formal parameters. It doesn't define the values for them. It just defines what kind of data that we want. The user will supply those values when they use this constructor. And then inside this constructor is an algorithm, the series of steps that we want the constructor to do. The algorithm for a constructor should be to set those member variables, which is what it does. We had a member variable for sides, and we're going to set it equal to the number of requested sides. And we had a member variable called color, and we're going to assign that the requested color. This lines up with our essential knowledge. The parameter list in the header of a constructor lists the types of the values that are passed and their variable names. These are often referred to as formal parameters. And a class contains constructors that are invoked to create objects. They have the same name as the class. So here's that definition for that die class. You can see we added that third constructor in the constructor section. So we have 3 different constructors to choose from. So a class can have multiple constructors. Every constructor needs to have a name, and that name needs to be the same as the class. So they all have the same name, die with a capital D, just like the class name on line 1. Each constructor needs to have a signature that needs to be unique. We will look at signatures more in depth in a later topic. But if we look at line 8, line 13, and line 18, each one of those is different. And a constructor needs to have a purpose. Its purpose is to initialize the member variables. So if we look at the constructor on line 8, it is just going to set the member variables to 6 and red. So if we call that constructor, we're just going to get a basic red 6-sided die. If we look at the constructor on lines 13 through 16, we get to pass in the number of sides that we want. And so then it will build that die with that number of sides, but the color will always be purple. So we do have some control over how many sides we will have on our die, but we don't have control of the color. And then on lines 18 through 21, that's the constructor that gives us the most control, where we can set the number of sides and we can choose our color. So when we have multiple constructors, those are known as overloaded constructors. Constructors are considered overloaded when they share the same name, but have different parameter lists. So line 8 accepts no parameters, line 13 accepts one parameter, and line 18 accepts two parameters. This aligns with our essential knowledge. Constructors are said to be overloaded when there are multiple constructors with the same name but a different signature. We saw what a constructor looks like in our class definition, but how do we use that constructor to make objects from that class? That's where our object declaration and instantiation statement comes in. We're working with the same learning objectives. We want to create objects by calling constructors without parameters, and we want to be able to create objects by calling constructors with parameters. Yeah, I remember that sound. That means that we are going to learn a new type of statement, our object declaration and instantiation statement. It creates an object in heap memory and assigns the variable a reference to the object's location. You'll see an example of what that line of code looks like in order to call a constructor to make an object from a class. So when you are using this statement, the first thing that you are going to type is the name of a class. We are not creating a primitive type here. So you will not type int or double or boolean. We are creating a reference type. This variable will hold a reference to where an object lives in heap memory. In our example, we are creating an object from a class called shape. The next thing we need to type is the name for this object. This is our user defined name. This could be whatever we want to call it. So in this example, we are going to make a square. Followed by the assignment operator. We are going to assign a reference to that reference variable. After that assignment operator, we have a new operator, which is the new operator. That operator requests a location in heap memory for the object being instantiated. Then we need to call one of the constructors. So remember, the constructors have the same name as the class. So that will be the same as the reference type at the beginning of the line. And then we have our parameter list. These are known as our actual parameters because these will be the actual values that we want to use when we are creating the shape. So we set the actual width and the height that we want when we are creating this object called square. So looking at that code example on the left, looking at lines 3 and 4, you can see our regular variable declaration and assignment statements. We are declaring a variable with the name width and we are assigning it the double literal 5.2. And we are declaring a variable named height and we are assigning it the value of 3.15. On line 5, we see our new object declaration and instantiation statement. We are declaring a reference to the class shape, and we are giving it the name rectangle. So at this time, we should probably take a look at that class shape on the right-hand side. So looking in that class shape, we see our three sections. On line 2, we see our variables or our attributes. A shape is going to be defined by a width and a height. On line 6, we only have one constructor for this class. And on line 12, we have one method that will calculate and return the area. Looking at that constructor on line 7, we see our formal parameters of my width and my height. So going back to the code on the left on line 5, we are naming this shape rectangle, and we are going to assign it a value. We're using the keyword new to request some space in heap memory to store our object variables. And we're calling that shape constructor, and we're passing in the width and the height from the variables that were defined earlier. Now it's going to get a copy of those two variables, so we're going to send in a copy of 5.2 and we're going to send in a copy of 3.15. And it is going to make our shape object for us, named rectangle with the width and the height that we requested. On line 7, you see another object declaration and instantiation statement. Again, it is of type shape. We are naming this one square. We're going to use our keyword new to request some space in memory. And we are going to call that same constructor as before. This time we're going to pass in some literal values instead of some variables, and then we will construct that object as well. So we created two primitive type variables and then we created two reference types. We made two objects. This aligns with our essential knowledge. Every object is created using the keyword new, followed by a call to one of the class's constructors. Existing classes and class libraries can be utilized as appropriate to create objects, and parameters allow values to be passed to the constructor to establish the initial state of the object. Here we have another class. This is our rectangle class. This rectangle class has three constructors, so you should try to write an object declaration and instantiation statement using each of these three constructors. So go ahead and pause the video, write your three constructors, and join us again. And so here you see an example of how those three lines of code might look. So we've been talking a lot about this reference type, saying how it is different than a primitive type. So we want to see how this reference type interacts with the computer memory. Our learning objective, we want to define variables of the correct types to represent reference data. So let's imagine your friend is having a birthday party and you get them a house. You can't just wheel the house over to them because it's too big. So instead of bringing them a house, you bring them the address of where they can go to find that house that you got them. So taking a look back on how we store primitive data, on line 3, we are declaring a variable of type int. We are giving it the name Pokemon caught, and we are assigning it the value of 52. So that goes into our stack memory with the name that we assigned and with that actual value of 52. So we're taking that 52 and we are putting it in a box. That box can hold 32 bits or 4 bytes of RAM memory. And then we're going to slap a label on that box. We're going to write Pokemon caught on that box. So it has a name, and inside of it, there is a value. So let's see how we store objects. So on line 3, we are declaring a variable of type die, and we are slapping the name of D6 on there. And we are calling the die constructor. So if we look on the right-hand side, starting at line 8, we see that die constructor. That die constructor initializes two values. It initializes color to red and sides to 6. Now, we cannot put two values in the same box. So we cannot store both of these values in the memory location labeled D6. So when we declare an object of type die and give it the name D6, we do get a location in stack memory and we do put the label of D6 on it. When we call the constructor, we build the member variables over in heap memory. And then we take that memory address and we store it in the variable that is in stack memory. And that memory is called a reference type. The reference type holds the memory location of the object variables. So compared to a variable declaration and initialization statement, we are declaring a variable of type int, giving it the name num, and assigning it the value of 5. If we look down in our stack memory, that is at the bottom of our stack memory, num, and it has that actual literal value of 5 in that memory location. When we look at our object declaration and instantiation statement, we are declaring an object of type die, and we are giving it the name D20. So if we look down in our stack memory, we see D20 in our stack memory. We are calling that die's constructor and passing in the actual parameter of 20. It's going to take that 20 and the constructor will then initialize the member variables. We can see in heap memory, we made a spot for sides and set it to 20, and we made a spot for color and we set it to purple. Now that constructor returns the memory address, and that's what gets assigned to D20. So if we look in our stack, D20 gets assigned a reference. It says we have a die at heap 01, and that's where we go to start looking for our variables. So these statements look a little similar, but they are a little different. On the left, we have a primitive type. On the right, we have a reference type. They both have a name. This is a name that we give it. We should follow our naming convention rules when we create these names. On the left, we have an expression that will be evaluated to a value, and that value will be stored in memory. On the right, we are instantiating with the keyword new, and we have a constructor call. And then when we look at the memory location, on the left, we are storing the actual value. On the right, our object data is stored in heap memory, and in stack memory, we have a reference to where that object data is stored. Now that object declaration and instantiation statement is actually two different statements. We have our object declaration where we are declaring something of type die and giving it a name. And then it's also the instantiation where we are assigning it the memory address returned by the constructor call. So what happens when we just do the object declaration? So on the right, we just have die d20 and then a semicolon. We are not calling a constructor. Something does need to get stored in memory. We did create a spot in stack memory called D20, and we do need to put a value in there. If we do not call a constructor, if we do not use that keyword new to request space in heap memory and call a constructor to build the member variables, Java will put in the keyword null. Now, the keyword null means has no value. So according to Java, all Java knows is that we want to create an object, but it doesn't know what type of object because it did not save anything in heap memory yet. So we cannot reference any of those objects variables and we cannot reference any of those methods until we actually build that object. All we told Java so far is that we are going to build an object and we are going to call it D20, but we have never built the object, so nothing exists in heap memory. When a reference variable is null, it means you requested space for an object but never made it. No object exists in memory. This aligns with our essential knowledge. The keyword null is a special value used to indicate that a reference is not associated with any object. The memory associated with the value of a reference type holds an object reference value, or, if there is no object, null. This value is the memory address of the referenced object. So we saw the parameter list for the constructors. We saw the values that we pass into the constructors. We know they're both called parameters. We're just going to take a closer look at those formal versus those actual parameters. Our learning objective, identify using its signature the correct constructor being called. So on the top, we have our constructor call. That's where we want to create an object. So we declare that object, we use the keyword new to request some space in memory, we call a constructor, that constructor will build the object and will return the address in heap memory where it put those values. These values that we pass in are called our actual parameters. We want the constructor to use these to initialize the member variables of the object. If we see what that constructor looks like in its class definition, remember it has the same name as the class, and then it lists the type of variables that it will accept and the name for those variables, but it does not give them any specific values. It's not the blueprint's job to supply specific values for those variables. These are known as our formal parameters. The actual parameters go into the formal parameters. So these are the types of values that will be accepted by our constructor. The actual parameters need to match these types in this order. Now, when we pass in our actual parameters, the formal parameters only get a copy of the actual parameters. They are not linked in memory. The 3.2 that we are passing in as my width, they are not linked. My width gets a copy of 3.2. So if we change those actual parameters after we initialized our object, it doesn't change the formal parameters and vice versa. There's no link between the actual parameters and the formal parameters. This aligns with our essential knowledge. A parameter is a value that is passed into a constructor. Those are often referred to as actual parameters. And parameters are passed using call by value. call by value initializes the formal parameters with copies of the actual parameters. So taking a look at what that looks like in memory, on the left in our void main, we declared two variables of type double, one called width, and we assigned it the double literal 5.2, one called height, and we assigned it the double literal 3.15. We can see both of those in stack memory. And then on line 5, we are declaring a shape, and we are calling the constructor passing in those two variables, width and height. Well, width and height will be evaluated to their values, 5.2 and 3.15, and copies of those will be sent to the shape constructor. The shape constructor takes those two copies and stores it in its own width and height, which we can now see in heap memory on the bottom right. They have the same value, but they are not linked. After this point, if any of those widths and heights change, it doesn't affect the other width and height. So after this point, we have our rectangle object with its width and its height. In our stack memory on the left, I highlighted that in blue so you could see where it points to in heap memory and the two variables that are associated with it in heap memory. If we decided to change the width variable on line 7 after we had already declared our rectangle, the only thing that changes in stack memory is that original width value that we changed. It changes from a 5.2 and it now becomes a 3.8. But if we look at the width in heap memory, the one that's associated with the rectangle, that doesn't change. There was no link between those widths because the rectangle only got a copy of that 5.2 value. And so now we can then create another object from that shape class called square, where we call in the constructor and we pass in that width twice. In that case, that constructor will just get a copy of that 3.8 for both of those parameters, and it will create that square. It will create another width and height in heap memory and store the memory address in stack memory. So everybody has their own unique values. None of these values are linked to any of the other values. So we mentioned a couple of times about a signature. I told you we would talk more in depth about a signature a little later. Well, that later is now. Our learning objective, identify using its signature the correct constructor being called. Imagine for a moment that you find out that the two stars from your favorite TV show are signing autographs at the mall. So you rush over there to get their signature, you give them the sheet of paper, and when you get it back, you see that they both have the very same signature. And then you're just bummed out because you can't tell one from the other and that you were hoping that each one of those signatures was unique. Because that's what a signature is. Everybody should have their own unique, different signature. And so you crumble up the paper and throw it out, and then you try to stop at the churro stand on the way out, and then you realize that the churro stand shut down, and then it was a complete wasted trip. Well, our code should be the same way. Every signature should be unique. So we have a box class on that right. That box class has 3 constructors. Remember, a class can have multiple constructors. They're known as overloaded constructors. So we are declaring and instantiating a box object on the left, and I want you to identify what constructor is being called. So on the left, we are calling a constructor and we are passing in actual parameters of an integer and an integer. So the constructor in our class that has formal parameters of integer and integer is the first one. It accepts the width and the height, and then it assigns those values to the member variables. All right, we have another constructor call. So try to identify which constructor is being called on the second object declaration and instantiation statement. Looking at the actual parameter, we are passing in a 50. So we have to find a constructor that accepts a formal parameter of an integer. And so we see this one, it accepts an integer for a width, and then it assigns that width to the member variable width. But what about this one? This one also has a formal parameter of an integer. It just has a different name. This one wants to accept it as a height and assign it to the member variable of height. Well, the names aren't enough to be unique. The computer doesn't know which one you want. It doesn't look at that 50 and understand that that 50 wants to be a width or that 50 wants to be a height. All it knows is that 50 is an int, so it looks for a formal parameter list that accepts one int. And it sees two of them and it doesn't know which to call, so we cannot do this. And this has to deal with signatures. A signature consists of a method name and the parameter types. The parameter names don't make a difference. Each signature in a class needs to be unique or the computer won't know which one to use. If we are just looking at the signatures, looking at the constructor on line 13, the signature is its name and its parameter types. So the signature is box, int. Its name is box, it accepts two ints. Looking at the constructor on line 18, its signature is box, int. And looking at the constructor on line 22, its signature is box, int as well. Well, those last two signatures are not unique. Constructors cannot have the same signature. So this box class would not work. So here we see our die class. Go ahead and try to identify the signatures of the constructors in the class. Looking at line 8, our signature is just die with no parameters. Line 13, we have another constructor. Its signature is die and it accepts an int. And on line 18, the signature is die, int string. So all of those signatures are unique. That aligns with our essential knowledge. A signature consists of the constructor name and the parameter list. So this is an acceptable class definition. That's going to bring us to the end of this lesson. You should review how you feel about those learning objectives. Hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.